Exception handling. In case of an exception, Python will stop the program and return an error message. This error message contains a description of the exception that occurred. Numerous types of exceptions exist. Some typical exceptions in Python are zero division error, name error, or file not found error. A list of built-in exceptions is given to the end of this presentation. In the input cell number 1 to the right of this slide, an example of a zero division error is given. In Python, exceptions can be handled. Therefore, the try and except statements are required. In the most basic version, the try statement is used with the except statement, which does not contain any detailed information about the exception itself. An example is given in the input cell number 2 to the right of this slide. Furthermore, it is possible to provide more details about the exceptions to be able to treat the different exceptions in different manners. An example is provided in the input cell number 3, wherein zero division error is treated differently. Additionally, it is possible to use an else statement for your try and except block. Thereby, the else statement is only executed if no exceptions occur. Furthermore, you can add a finally statement to your try except block to ensure that this block of code runs regardless the appearance of exceptions every time. Two different examples of using else and finally statements in your try and except blocks are shown to the right of this slide. An overview of the built-in exceptions are provided on this slide. In case required, it is also possible to add user-defined exceptions. Errors and exceptions. It is common sense that programming errors are rather unavoidable. In programming with Python, the errors can be distinguished in 3 categories: syntax errors, exceptions, and logical errors. For each of these categories, an example is given to the right of this slide. In the input cell number 1, we see an example for syntax errors. Thereby, basically, the parentheses of the print command are missing. This type of errors are rather easily to find and are typically shown by the interpreter. The next and more complex to find errors are exceptions. An example for exceptions is given in the input cell number 2. Thereby, a divisor is defined by a list of integers, and this list contains the number 0. And as we know, it is not possible to divide a number by 0. This will cause an error, as you see in the output of the cell number 2. Typically, the most complex errors to detect are logical errors, as they don't show up easily. An example of a logical error is given in the input cell number 3. First, this year and the birth years are defined. Afterwards, the age is calculated by the help of these variables. Notice that the months are missing. So this program will deliver wrong results depending on the respective months of the year. This type of errors are called logical errors. Logging format attributes. To the right of this slide, an example usage of Python logging is shown. In the input cell number 1, first the logging module is imported. Afterwards, some basic configurations are set. In the third line of input cell number 1, an example message is generated. Paying attention to the line number 2, some basic configurations are done. You see a keyword for the time and for the message. In the output of this cell, you see the time is printed as well as the message that is defined in the third line. There are a number of attributes that you may use in order to customize the level of information that is logged. In the table to the left of this slide, an overview of the available logging format attributes is given. On the last slide, the descriptions of the logging format attributes are provided.
Welcome to the last unit video of this course on modules and packages. Modules and packages are ways to thematically organize codes, for example functions, in Python for supporting their reuse. Modules are basically files with the ending py, and packages are folders of modules. You can import existing modules into your application to use the encapsulated functionalities instead of rewriting everything yourself again. We have actually seen this in previous units. For example, the import and usage of the logging module, which provides logging functionalities. So you here see a code example which first imports the logging module, and then it uses functions defined in the logging module. For example, basic config is a function, debug is a function, and the name debug is also a name which is defined in this module. So let's note it down here. Here we have logging as a module. And it's nothing else but physically a file with ending py, which is stored on your computer, and it comes with the Python installation. So the first goal of this video is that you know how to import and use modules. Now, when talking about code reuse, an important issue is improving code readability in order to reduce the time to be able to apply existing codes or to track down errors or to add enhancements. And one means by which you can improve code readability is documentation. Hence, the second goal of this video is that you know how to use Python documentation. Moreover, as mentioned already in the first unit video, Python comes with lots of available packages, particularly for scientific computing and for data science. Hence, the third goal of this video is that you know some